Hi class. Now that we have covered air masses, let's now take a look at fronts and see what the relationship is between an air mass and a front. And so we're going to do that by looking at how a front is actually created. And it all starts with an air mass. So let's start with by drawing an air mass. And an air mass basically is a nice little bubble of air 1,000 miles across, as we mentioned previously, and a couple of miles in height. Again, this is the height is greatly exaggerated in this particular case. So this air mass is created when air stagnates over a source region. So let's say this is the Canadian prairies. And so this air mass sits over the Canadian prairies for an extended period of time, takes on the temperature and moisture characteristics of that source region. So that would be continental because it's over land, so it's going to be dry, and polar because it's in more poleward latitudes and therefore is going to be cold. So we have a continental polar air mass, and this is going to be represented on a surface weather map as a great big high pressure. All right, so there we have our air mass, continental polar air mass. And this is just going to sit there and continue to take on the temperature and moisture characteristics of the source region until something comes along, something called the jet stream. So let's draw in a jet stream here. And the jet stream comes along, and it's almost like the police of the atmosphere. It's like, you've been sitting here long enough, you need to move on. So the jet stream comes along, and it's going to start pushing this air mass, this continental polar air mass, right along. And as it pushes this air mass along, this air mass is going to become kind of distorted a little bit. And so it'll get more teardrop shaped. So it'll start looking kind of like this. And again, that's because the jet stream is pushing it along. Now, the important thing to realize is that there's friction taking place at the surface, okay? But aloft, a couple, 3-4 miles above the surface, there's no friction. And so that's the reason that this air mass gets kind of distorted as it moves along. Friction at the surface is causing it to move more slowly at the surface. No friction aloft means that the top of it is going to move faster than the bottom and get distorted like this. And again, this continues as this air mass moves along. The jet stream continues to blow, and it continues to move this air mass along. And as it does, it gets even more distorted. Now, again, I'm exaggerating here, but it'll look something like this. All right, so notice the leading edge here. So you got this air mass. This is still continental polar air, and this continental polar air is being pushed, in this particular case, from left to right. And notice the leading edge of this air mass is going to be very steeply sloped. So the leading edge of this air mass is steeply sloped. Steeply sloped, okay. And this is actually going to become the leading edge of continental polar air mass, actually becomes a cold front. Okay, and our cold fronts typically are relatively steeply sloped relative to a warm front. And later on, when we start talking about warm fronts, the warm fronts are actually going to be back here at the tail edge of this continental polar air mass. So eventually this continental polar air mass is going to move down into the United States, and eventually is going to move off towards the east, going over the Atlantic Ocean. We call that a retreating air mass. So while this air mass is advancing, the leading edge is going to be steeply sloped. That's going to become a cold front. As the air mass moves off towards the east, The trailing edge here, we'll call this the tail edge, has a pretty gentle slope to it. And that actually is going to become a warm front later on. Okay, so next we're going to talk about cold fronts, and then after cold fronts we'll take a look at warm fronts. But this is basically the start of how this all begins.